Good afternoon. My name is Philipp Giese. I would like to give, in form of a screencast, something which I wanted to present during the German Bitcoin Week, a series of events surrounding the Unchained Convention this year, which was held in Frankfurt. The topic is, as we can see in the title, Be Your Own Blockchain Analyst. So the idea is how interested people can use tools, in this case R, to get some information out of the crypto market. Why should we think about that? Why should we be our own blockchain analysts? I think one main reason is because one general motto around blockchain technology, and especially around Bitcoin, is the short sentence, don't trust, verify. So blockchain technology or Bitcoin is about trust minimization. And the problem now is that is on the one hand true. On the other hand, if we look into the reality, we see that crypto analysts are oftentimes simply hiding crypto. And even though they then claim this is no investment advice and stuff like that, it's obviously that they are hyping crypto for the value of their own funds, so to say. They're simply shilling it. And so, as I already said, also for analysis work, we have to have this mindset, don't trust, verify. And so the goal of, I think, everybody in this field is to participate, and that we are able both to distinguish solid analysis from FUD, hopium, and FOMO, and to offer ourselves something like that. Just before I start this course, I would like to make some things clear, which this course is not, because I think there a lot of people had the wrong assumptions about the aim of this course, or about this course is of course a little bit exaggerating about this workshop. It's not an introduction into technical chart analysis. I think there is much better work all around the internet. You can simply search for Bulkovsky and pattern, for instance, and find there some useful information. Also on TradingView, you can find numerous information about that, though. So it's not about that. This screencast is in no way an investment advice. And that I don't simply say as an excuse for later on shilling my own bags or something like that. I assume that most of you people are into Bitcoin, and yeah, in that sense, I cannot tell you anything more, so to say. It's not a blockchain programming course. For that, I would refer you to stuff like programming Bitcoin, for instance. Mastering Bitcoin is also quite interesting in that field, and so on. It's not a general introduction into data analysis, even though I try to present some baby steps which are then obviously also applicable to other fields. And it's also not an introduction into general blockchain technology. First of all, we won't need that in this workshop. And secondly, I think that you all listeners know that a blockchain is a chain of blocks and so on. And if not, there is numerous information about blockchain technology and distributed technology out there. So what is this workshop? What we try to do here? First of all, my goal is to present a little bit, or to ponder a little bit about the mindset which you should have both when you are making your own analysis and when you are reading the analysis of other people. So at first we start by stating what is the correct mindset. Second, we will discuss our main tools. And as a main part, after this first introduction and getting our hands a little bit dirty, I would like to make, let's say, an example analysis work. So how you could approach analysis work with R, and that we would like to do by a classical model for the Bitcoin price by looking at Metcalfe's law. The last point is not that interesting now for the screencast. I had the idea to make group work afterwards. Let's say in that sense, I hope that after this screencast, people would be inspired to do their own work, and I would be happy to see the applications you find for using R in the crypto field. Just before we start right in, some words about myself. My name is Philipp Giese. From my educational background, I'm a physicist, so I have, like a lot of people, especially in the crypto field, I am not a computer scientist or a data analyst by education. A lot of you will know me from my German-speaking work at BTC Echo, where I was one of the editors and the chief analyst from 2016 to 2020. Now I'm a technology consultant at a project sponsor, and my former work turned again into a passion and to a hobby. So I am a hobbyist crypto researcher or something like that. Yeah, now let's start. I already have explained why I think having the correct mindset at the crypto market is quite important, and I think it becomes much more important again as we are now entering, or hopefully entering, another bull market. And while bull markets are quite nice for the price, it's oftentimes quite horrible for the news outlets out there and for the Twitter feeds and so on. The reason is you read then lots of crap, and I have here collected some headlines and some quotes which show what is the problem with analysis work and analysts who are simply hyping. I mean, the example from Hodlonaut, I think he said it in a ironical way, but a lot of the other things were not in an ironic way. They were either tautologies, like the BTC price can go up, but it can also go down. A lot of FUD, devastating Bitcoin wipeout, could see the price go sub 1,000 US dollar, or I put at least a 10% chance on kind of a big flash crash. We are now horrified by that, especially because the articles themselves provided not more information than these titles or quotes. Of course, we oftentimes have also the other extreme, this hyping, this FOMOing. 2050K Bitcoin price prediction is now conservative, says Tim Draper. Of course, everybody got mad after that, or got crazy after that, and yeah, we have to pump our bags and so on. And everybody knows the last example in the upper left, that John McAfee promised to eat his dick if Bitcoin fails to hit 1 million at the end of this year. Well, let's see that. I mean, money printer goes brr, so perhaps two effects are cooperatively working on making this goal achievable. But at least I, for myself, highly doubt that. The problem is, I think, not something which is only focused on the crypto market. It's also nothing special to analysis articles or something like that. I think it's a problem with the reception of everything which has the label science. I don't say that in no way as somebody critical of science. I mean, hey, I have a PhD in physics, so I'm of course completely pro natural sciences and so on, and about critical thinking, and so I'm also 100% pro. The problem is that really valuable fields turned into memes, and that you can see when media writes articles where the headline is something like blah 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 comma says science or something like that. So an overhyping of science led to the opposite effect from something desirable. People were becoming less and less critical only because there somewhere was the label science. And you also saw that at two sentences floating around the social media. The first one is I fucking love science. The second is I believe in science. As you can see, I made there something, I indicate that something is missing. And obviously, what is missing is science has to be good. And two sentences which I can completely support and am completely pro, that is I fucking love good science. Sorry for the F bomb. and I believe in good science. And because I believe in good science, because I think there's a high value in good, well-researched science and analysis work, I am really against badly researched papers, against emotional articles who claim to be scientific but are simply ideological and so on, because they are something which then oftentimes gets mixed up with good science. Okay, but how can we distinguish good from bad science and hence also good from bad cryptanalysis? And I think three things are something which can help us form the correct mindset. First of all, it's presented in a calm manner. Nobody would say something like, I will eat my own dick if if we don't find a way to detect gravitational waves. He will then perhaps say, I highly doubt that because, and there we are at the second point, it is well reasoned. He won't simply give some opinion and then some mumbo jumbo bullshit about, yeah, because math says so, or something like that. Good scientific work will help the reader understand how some author comes to to the presented conclusions. And the third thing is something which a lot of people, on the one hand, know in their own life, but they don't know the correct term for it, and that is good science is falsifiable. Now, what is falsifiability? It's a principle of the philosopher Sir Karl Raymond Popper. I won't go into too much details. Perhaps one good translation for falsifiability is that some theses can be challenged. And to show what I mean here, three non-examples. So three things which are not falsifiable. One Bitcoin equals 100 million Satoshi. Well, even though that's correct, it's a definition. Yeah, you don't. If I write a paper now about that sentence, nobody will learn anything new. So it is, even though it's correct, it presents no new information. And one reason for that is, since it is a definition, there is no way to challenge this sentence. It's similar to saying a circle is an object where each point has the same distance to another point which is not dotted or something like that. At least in a Euclidean geometry on a plane, that is then a circle. Yeah? And you cannot challenge it, because if you challenge it, then you simply challenge one word or one definition of a word. The second example, we also saw that the Bitcoin price can go up, but it can also go down. Well, it's of course true, but it cannot be challenged. Oh yeah, it can be, it can go sideways. Yeah, okay, then extend the sentence. It can go up, but it can also go down or sideways. And then we have something which is a complete tautology and is not challengeable and hence provides no information. And the third thing is something which is, I think, the most hazardous thing of them all, because it sounds like something scientific, but it is more about emotions, or the emotions which readers associate with different of these words. And here we have something regarding the Bitcoin ecosystem. A lot of Bitcoin maximalists have a tendency towards toxicity. We oftentimes read something like that about Bitcoin Twitter, and yes, we have to admit there it's not always sunny in Bitcoinia, so to say. But this sentence is again something which is not graspable, cannot be grasped. So it's not a real hypothesis because you cannot challenge it. What is a lot of Bitcoin maximalists? Who exactly is a Bitcoin maximalist? What is a tendency? And what is the toxicity? So you cannot bring up an example which would disprove this sentence. And, and hence, it's a really, let's say, dangerous sentence, because it can lead to an anti-Bitcoin sentiment, and that's based on something non-falsifiable. So you can think of several of like these statements regarding analysis work in crypto. I mean, we can regarding that, we can go back here and think about, for instance, the sentence devastating Bitcoin wipeout could see the price go sub 1,000. Yeah, what kind of devastating Bitcoin wipeout? What does he mean with could? Could is such a word which is oftentimes connected to non-falsifiability. Could see the price go sub beyond 1,000 US dollar. On which time frame? How far beyond sub 1,000? At least he says sub 1,000. That we can say in his defense. He don't simply say could see the price drop massively. That would be then completely horrible. But that simply as an example, as just one example, how this can also be related to analysis work. Falsifiable thesis can be challenged, so that is what we can get out of here. A good thesis has to provide enough information that somebody can say, yeah, but moment, if we see this and that, then your hypothesis is null. That means that they should be formulated in a falsifiable way. And for data analysis, that means that you should formulate a hypothesis so that future developments can confirm or contradict the hypothesis. Perhaps as one thing regarding stuff like using analysis work for investment and so on. Of course, that also means that good hypotheses can lead up to good supports and resistances, where you can say if the Bitcoin price behaves as in this model, this narrative has not changed. So that can also be quite interesting, but that as a small side note. Now, what does that mean for the typical workflow in data analysis and hence also in crypto analysis? It is oftentimes depicted as here. That is a picture from the good book R for Data Science from Hadley Wickham, one chief developer from our studio who has contributed multiple packages for R, and one of these package families we will also use today. And what you do there is you get the data, get it in the correct form, transform it in a more specific form, visualize it, make a model, and here you can oftentimes not be trapped, but that can be that you have to refine the model and so on and so on. And then you communicate the data. This part here, this core, is called the exploration. So let's say the research in itself, and we will look at these different parts now in the rest of this screencast. And we will now get also our hands a little bit more dirty, so to say. Here I would like to present the main tools, and of course, if you follow the screencast, let's say in an active manner, you can also install that in parallel. I will later on show one way to participate here. Our main tools are R, you know what I mean, is first of all R as, let's say, the core of all this. Then RStudio, Shiny, and several APIs. What that now all is, we will take a closer look. R is a statistical programming language. Besides the Python, I think it's the most used programming language in the field of data science. One reason for that is the tidyverse, which is one special group of libraries which make this whole data analysis workflow I've shown here quite easy. And that's also why we'll use that. How does R look? It looks like that. What that all means, we will discuss later on. I will particularly, as a first example, discuss this code with you guys. But now I just wanted to show you how R might look. A second tool is RStudio. Though it's most of the time optional, you can write code like this one in any editor you would like. It's oftentimes, as you know from other IDEs, it's oftentimes quite nice to write in an IDE which is well known for a good interaction with the underlying language. It's partially from the people, or it's closely associated, let's say, to the tidyverse. It's a great tool for literate programming. All the slides I did here, etc. This whole course was made with the R and R Studio. As I said, it's most of the time optional. I also love work with more minimalistic editors such as Vim or Cocoon in my case. But sometimes I still love to work with that, especially if I do literate programming. Perhaps for people who cannot associate something with that expression, literate programming means that you make a mixture between writing code and writing text. And just as an example, let's look how the code for this talk looks like, and you can see it here. You see it's a mixture between commands, but you can see there are also well-structured markdown text, and yeah, it's then it's a simple new interface. Another main tool is called Shiny, and from a code-wise perspective, it's another package for using R. But what does that do? The nice thing which you can do with Shiny is you can make interactive plots. You can see here a plot for the Bitcoin price um, during the last week. By the way, if this plot would not have been interactive, then it would be the same output as that code I presented earlier. But the nice thing is now you can, for instance, right now, Ethereum. And let's see, yeah, voila. We have then the price of Ethereum, and that you can do with a multitude of other crypto assets. I simply used here the API of CoinGecko. Yeah, apropos API, that is our fourth tool or fourth group of tools. APIs are, yeah, let's say sources of data. It stands for Application Programming Interface, and it's a gateway to send and receive data in the internet or on web pages. So it's a quite convenient way to get some data to play with it. So you don't have to download multitudes of files or something like that, but simply scrape the data from the net. Okay, now let's get our hands a little bit dirty. And one way to really, on a practical manner, now start here with me is to make an account on the RStudio Cloud. That would be here. Simply to show it to you how it looks like if you're not logged in. It looks then like that. And you can then, via signing up, can you make a free cloud account. For this example, a free cloud account will suffice. I have also to say that I don't have extended that account to premium. For my little hobby project, it would suffice. And if I would like to do something more demanding, I would work on my own machine, not in the cloud. The advantage about the cloud is that you don't have to install both R and RStudio. If you would like to have that all at home, you would simply download RStudio at the RStudio homepage for the for your system, and do the same with R. Yeah? You would go here on download, and the other thing which you would install is R, which you can find at R project. And if I remember correctly, let's see if I remember correctly, it's not secure. That is then let's search for that. Sorry for that little hiccup. rproject.org, yeah, of course, org. My bad. Yeah, you can download rproject.org here, and yeah, then you would have a local copy. Another advantage about the cloud is obviously that if you have, for instance, if you work on something like a Pinebook, which I can really appreciate because that is my second go-to laptop, Um, there you will have the advantage that there is no RStudio for the Pinebook because there are no is no RStudio for ARM systems. And in that cases, it's always great to work with um, to work with RStudio Cloud. Now, if you have opened up an account, what you would do is yeah, you register a new account, and then you would click, and we do that now together, on new project. But what we especially will do is we will go on new project from GitHub repository, he says here. From my own experience, I can say you can also do that with a GitLab repository, which is obvious because what we are using here is, if we are technical, is a Git repository, right? And if we now do that, if you now follow along, what you would do with that is you would load all the code which you have, which is downloadable, etc. Here, you would load into this new RStudio instance. I do that now with you simply to show you how to proceed further. Yeah? As you can see, it's quite fast actually. It might be that some of you Linux users will have problems that there it won't open this window. I had that problem, for instance, with the also great browser, but unfortunately not usable here, with Qt browser. And I can imagine that that is for some niche browsers, that might be a problem. Yeah. So now we have all the code, and I have now written here sip of coffee because for me it took always quite a while. Now I'm quite positively surprised to see how fast it went. One thing though, which you will see then, is that we have currently in this regarding the packages which are installed here, we will see that most of the packages we need are not installed yet. So if we, for instance, try to run, let's start with this example. If we try to run that, what you could do then is, for instance, mark everything and then click on run, and you can see we have a bunch of errors. And what is the reason? There is no package called tidyverse. And he shows you something. Packages, tidyverse, loop redated, and JSONLite are required but not installed. Yes, then let's install it here. You could have also written down install packages, but yeah, we were now lazy. I just would like to see whether he really has installed it now, because it's, oh yeah, and he has installed it. As you can see, something is happening in the background. That is why it takes here now that long. And the reason was that this job was not started yet. But now yeah, it installs everything, and as you can see, there you can really drink a coffee, right? As I promised, we all have now time for some coffee. Yeah, now I'm back again. I got myself something to drink. Let me just take a small sip. I already checked whether the tidyverse is now installed. By the way, it took around 1.5 minutes. So yeah, it's perhaps not enough for a coffee, but for getting a glass of water or a glass of Coca-Cola or something like that, it's more than enough time. Mm. The same we can now test um, with the other two libraries we will load. I will tell a little bit more about that in a second. And yeah, everything is installed. And now let's really proceed further. We have now opened up a new project. We have installed at least for this example, all um, all packages we need. And what the general approach in all data scientific work with R is, you get the data. Most of the times when we are dealing with crypto data, via API calls. We scrub the data or tidy the data so that we can work with it. So we bring it in a readable format, perhaps transform it a little bit, so that in the end we have something, let's say, useful. We visualize the data so that we can see what happens. It's oftentimes better than to look at a bunch of numbers. And sometimes it might also be quite good to model the data. And at the end, we brag by reporting the results, write an article about that, make a Twitter thread with great images we produced with R or something like that. So that is the general approach. One thing which I have, which is missing here, is something we see now here. Perhaps as a 0th step, we should write load the correct, the needed libraries. And in our case, we need 3 libraries. The first of them is the tidyverse. The tidyverse, as I said, is something which is some family of packages. We can simply um, look at the URL. It's a family of packages which is made for interacting with data. So if you would like to learn a little bit more about that, there's this site tidyverse.org. You can learn quite a bit about the tidyverse by the book of Hadley Wickham and Garrett Grolmont, which I already mentioned, the R for Data Science book. And yeah, and we will work with it. So a little bit you will learn here. A second package we use is the JSON Lite package. Why we do that? Perhaps I can show you that in a, let's say, in a really blunt way. We do that because we work with JSON data. As you can see here, the first 2 things we do is we load a distinct URL. Perhaps if we do that really step by step, we load a distinct URL in a variable. Yeah, that is done here. And if we now do this command, let's start simply with this command. What has happened here? Wow, we have now a lot of numbers. Right now we don't understand what these mean. We will discuss them in a second. Let's look at this URL in our browser, and then we see something like that. And aha, we see already that something like prices stands here. And then we see a huge number. And beside that, something which is, at least if we look at the first digits, before this dot, that might be actually a Bitcoin price, right? And that too, because we know that the Bitcoin price is currently about 1,200 something, but we have there some different information. We have market caps also here. That confirms our hypothesis, because the first number is the same as that one, and the second is a huge number, about around 200 billion. It should be right. Yeah, 200 billion, and yeah, so that is the market cap, and and we have here total volumes, which is the trading volume. We all get that from CoinGecko. Yeah, as you can see, this is data which is looks as if it is machine readable, and that is actually the case that we have done here. As you can see, there are these the volumes are here, and so on. So we have there, with the help of this so-called JSON format, that is also why we work with JSON Lite and use the command from JSON, we have something where we can work with from the viewpoint of a machine or of R. And for that example here, we only wanted to focus on the price. So if we simply execute that, we get we focus on the price. So volumes and market caps, as before, as we had before, we don't have here now. And now you see there some other command which is called as tibble. And why do we do that? I can show you more. Yeah, there is a warning was created which we can ignore right now for for this example, but obviously it's oftentimes quite good to read the warnings, especially if you see something like this warning is displayed once every 8 hours. That means then, of course, that if we ignore it, then we ignore it for 1 day, so to say. And yeah, what he critiques is that I don't provide that I haven't provide data with column names. We will fix that in a second. Um, right now we are happy with that. So what does stibble do? We see before before we used stibble, we had a huge table which goes on and on and on and on and on. And oftentimes that might be a little bit unhandy. So sometimes it's quite nice to see only the first 10 rows or something like that. That is something which you can do with a tibble. But what is much more important is the tibble is the native data structure for the tidyverse. You can do a lot of stuff now with this tibble, and we also will do now a lot of stuff with it. What we will do at first, we are quite unhappy with these generic column names V1 and V2. It would be better if we give it some better name, right? And we do that by piping our our tibble data. At first we save our tibble in a new variable which we call data here. Now if I write data, we see the information, by the way, without the warning. And now we can pipe this data into another command. What that means is we can, of course, also write something like most of the time I pipe, so it might be that I do now I will now invoke an error. But let's see. Yeah, it was correct. So technically, we could also work like that. So simply write the variable or the tibble, in our case, the tibble with the name data, in the command. But using such a pipe is always quite nice because oftentimes you have workflows where you would like to work with this data in modified first in this way, then in that way, then in that way, and you don't want to work every time with something like a temporary a TMP variable which you only which yeah gets overwritten with each command and something like that. That is a little bit more readable because you see then, okay, data gets renamed, or the columns of data get renamed. We mutate one of these renamed columns, and we plot it. To the plotting we come later on. Okay, let's rename this data by piping. And he does that. Fantastic. Now we can discuss this step here. Mutate time as datetime equals time divided by 1,000. Why do we do that? As I already said, this long number is some time information. Now, obviously I don't know how deep into nerddom you are, but perhaps you know expressions such as Unix time or Unix epoch. And this is a Unix-specific time format, which is again quite readable for for machines. I mean, uh, because it counts only seconds or milliseconds. There are two different standards. Yeah? Here in that example, it counts the milliseconds which have passed since the 1st of January 1970 at midnight. This is, of course, for us humans, it's quite a clunky time format, but on the other hand, for a machine, it's really nicely readable because the human time is quite clunky with 1 minute equals 60 seconds, 1 hour equals 60 minutes, 1 day doesn't equal 60 hours, but 24 hours. 1 week doesn't equal 24 or 60 days, but 7 days. 1 month doesn't equal does neither equal 60 nor 24 nor 7 days or weeks, but 4 weeks or 30 to 31 days, and so on. You see, human readable time measurement is quite complicated for machines. And for a machine, the most simple way and the most possible way is to count something like seconds or milliseconds from a starting point. And that is which the API of CoinGecko provides, the time in a Unix epoch. But we would like to have it in a little bit more readable time and do that by piping our tibble with renamed columns into the mutate command. And if we do that with the sDateTime command, just to show it to you what the sDateTime command does, we write here now, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Let's see what kind of date time that would be. I don't know it exactly. That, for instance, would be the 13th of February 2009 at a distinct time. And so a Unix epoch gets, with this command, formulated as a more human readable time so that you can see the date and the time respectively. Why do we here divide it by 1,000? Because in this distinct application of the Unix epoch, CoinGecko uses one where the milliseconds are counted. If we won't do that, just to show it to you, if we won't do that, we would obviously get complete rubbish as times. We would be in the year 52,496. So we would be much more in the future, even compared to science fiction such as Warhammer 40k, if somebody plays the Space Marines or something like that. Yeah, so we divide that by 1,000, and if we do that, then we are quite happy and have reasonable times. As I said, the times we see here are for a distinct time frame, and that is something which I forgot. How did we get the times? We used the API syntax from CoinGecko, and there you could, sorry, if we go to, yeah, now we are here. And there the whole syntax is explained. And if we would look there a little bit further, then we would see the whole syntax. For this command, what we do there is for specific coins, we would, in that case for Bitcoin, we would like to have a market chart. So charts for price, volume, and market cap. They should be labeled against the US dollar, because that's the standard, right? And we would like to have information about the last 14 days, which we have. Yeah. So because the first time was from the 16th of August, which is 2 weeks in the past. Okay, now we have data for the last 2 weeks. How can we now plot that? There the ggplot2 package comes to our help. We loaded that together with the tidyverse. The ggplot2 package is one small aspect, one sub-package of the tidyverse, so to say. And if we do that, let's start at first quite simple, because that would be a little bit disappointing. If we only write ggplot and then as so-called aesthetics, as the information we would like to present, we choose time and price, so the two columns, we would end up with something like that, with an empty chart. So, bummer. What have we missed? We have missed calling ggplot what type of plot we would like to have. Let's say we would like to have a line plot. A line plot would be, in that case, I think the most reasonable choice of plot. And that if we do that, then voila, we end up with a decent, acceptable plot, right? And now what is quite nice about ggplot, similar to what we discussed before regarding piping data from one command to another, what we can do here is we can build up the plot by adding new commands with this plus. Yeah? That, of course, doesn't have to stop here. You can, first of all, could even add more information or more data here. And what you can also do, which I did, was that you change a little bit the look and feel of the plot. I made it a little bit. I'm not the biggest fan of this gray backgrounds. The main reason is this is the standard background, and at one point you have seen that a little bit too much. And yeah, now we also have changed a little bit the labeling. Here you don't see time, because if you have there some dates, it's obvious that this is a time axis, and here I wrote price in USD. So with that, with 10 lines, we have our first plot. Congratulations for that. That's really nice. So to summarize again, after we loaded up the mandatory libraries, we got the data via API calls. We scrubbed the data so we can work with it. So we changed for in that case, the format of the datetime. We visualized the data. Right now here we skip the modeling, and right now we haven't bragged by reporting it because we only made one plot. That we did now, and we can of course now make an interactive plot. Well, how can we do we end up with something like that? It's more or less an extension of what we already did here. We will not go now through all the code again, but we will look at it a little bit. I did it here in a so-called R Markdown file, but let's focus on that part here. Sorry, by the way, for this wrong labeling and so on. I simply opened up a Shiny presentation and forgot to delete the stuff which we don't need. Anyhow, what we did here was, first of all, that I can still show what this command does. What we did is we invoked the name coins list and made from that a variable called coin list. And what we have there is we have three informations. We have an ID, we have a symbol, and we have a name. The ID is similar to what I called about Unix epoch or something like that, is more readable, more usable for the API than the normal name or the symbol. It's sometimes not a unique symbol, but used by one normal coin and one really unknown shitcoin. So it's oftentimes better to work with an ID because that is really unique for every asset. Okay, now we have this list. Why we have this list? Just to remember us, we would like to have such a menu where we see the names and not simply the IDs or the symbols. And so that is why we stored the data here. And now what we do with Shiny is we define two things. We define an input. The input, it's a function called select input, so an input mask where we can select one input, yeah? And we give that a name, a label, and as choices, we give it this column here. If we do that manually, then we end up with something like that. And as a selection, we select Bitcoin, because Bitcoin is the standard. Now, as output, there we get a little bit more. It gets a little bit more complicated. We would like to render a plot because, again, we would like to visualize something. And now the problem is, while we are selecting here a coin name, we have to select the respective coin ID, and that we do with this selection here. If I would press now return, we would end up with an error, but let's do it in a manual manner and search for Bitcoin. And as you can see, if we subset this data, if we look for the respective coin ID where the coin name equals Bitcoin, we end up with the correct ID. The same is true for Bitcoin Cash, and we can do this experiment 1 million times, which we obviously won't do, but duh. Now what we do with that is we construct our URL, because we would like to change this part. Just to remind you, here in our small example, we had the same URL code, but we had here standing Bitcoin, the ID for Bitcoin, and now we have here some placeholder, some variable, which we filled up here. And besides that, we did the same we did beforehand, so I won't go into detail here. We simply have found a way to make this URL a little bit more variable dependent on the inputs. So great, we have now made our first R example, and we have now made our first shiny example. And as I explained, we defined the data, we defined the inputs, and we defined the outputs. And that is how you get to interactive plots. Quite inconvenient, huh? Now, I wanted to start with some more or less basic examples, but oftentimes, I mean, plotting for oneself the Bitcoin price is nice and funny, but to be quite honest, I mean, for plotting the Bitcoin price, which we can get from CoinGecko, we can also simply go to CoinGecko. The same is true for data from other sites. So what I wanted to present as the core of this screencast is to make a case study to get some data in a fashion which we cannot get in that fashion at the original source. And for that, I wanted to look at the Bitcoin price and at Metcalfe's law. Why Metcalfe's law? We go to that later on. For that, we won't use the data from CoinGecko, because CoinGecko is great if it's only about prices or market caps and so on. But if you would like to be a little bit more closer to what happens on chain, not complete information from the blocks, but yeah, how much transactions have happened and so on, then CoinGecko falls short. But Coinmetrics is regarding that quite nice. And even though there is a quite pricey version of the API for premium users, a lot of interesting stuff can be done with the community API. It's a so Coinmetrics is a crypto-focused analysis and visualization platform. They curate hugely interesting newsletters with various data-heavy topics. And as I said, the data is accessible via API. You can play around already a little bit with the data on their site. That is then, for instance, let's see. That was now my problem. Network data charts here. They changed quite a lot since I made that screenshot, right? You can play a lot around on the site itself. However, what we will do is we will get the data from the API. And the idea of that is at first we will do these two steps here. We will call a distinct URL, which is a base URL. We say what we would like to measure, say metric data.csv, because we would like to have the data in a CSV format. And as metrics, we define what metrics we would like to see. So we give then a list of metrics we would like to investigate. A complete documentation you can be found here. We are then here at the Coinmetrics API of the version 2. Okay, enough talking, let's get the data. Before we get the data, perhaps one thing I'm using here, we will install the package. If you go along with me, we will install the package Patchwork. Patchwork is really great if you would like to make plots with different subplots. And that we will do, because that's funny. As you can see, that takes now a little bit a while. I don't know why, but yeah, now he is installing it. Let's see and hope that everything works, because of course, if you do such things as a mixture between screencast and live coding, it's quite an invitation for stuff to break, quite an invitation for Brave to show some advertisements we right now don't need. Naja. We invoke the Patchwork library simply because we can. And now let's try simply to show how that thing then works. We invoke a command. We read again a CSV file. And as I said, let's switch here back. As I said, we have a base URL, which is community AP blah 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 /assets. Sorry. Then what is BTC? Here we are working with symbols, not with IDs. And as metric data, we would like to have a CSV file. We would like to have a price and the number of active addresses. And if we start that, let's hope, we end up with information from the dawn of Bitcoin, where we, of course, at first never had a price. But starting from the 9th of January, we had some active addresses. 19 to be precise. Quite interesting stuff. And here we have now seen the start. Oftentimes we are more interested at the end of it. And to show that, let's do it. Sorry, apologies. If we do that, then yes, we see the active addresses and the price USD. Quite neat. Okay, as we have already seen, we use the tidyverse, a library collection devoted to data analysis and data visualization. I showed you already what we can do with it. With read CSV, we read the data in a distinct format, as a comma-separated values. To prove that, perhaps that I can still do is where I can open that in a new tab. We all remember how the API call from CoinGecko looked like. That was a JSON file. A CSV file is simply where all the columns are separated by commas. Okay, it's nice that we have now the data here. We would like to make a plot out of that, correct? And let's do that. We use for that this here. We have all the data in Daten. You know, I'm from Germany, and that's why I speak of not only of data but also of Daten. And voila, we have price information. Great. And what did we do here? We piped the data into a graphics command called ggplot. We already showed that to you, and I also explained to you the function of ggplot, that you at first get the data into the graphical, let's say, environment, and then say how you would like to plot it. And use data from Daten to make a plot where time and price UST are as aesthetics is the technical term here. And we would like to do a line plot. And if you would like to know more about the ggplot, you of course either can look at the tidyverse page or at the ggplot page. Plot that I have to find at first. Yeah, ggplot2 tidyverse.org is a really good starting point for a lot of the things if you would like to ponder about ggplot. But you can also learn quite a lot directly in R. You can then, for instance, call that one, and then you open the help for the ggplot command and really learn everything about that. Okay, and now let's combine some plots. We have done a plot where we only see the price. We see it here. Yeah? And now let's combine a little bit. Let's make two plots out of that. And for that, we at first load our plots into variables. I'll show it to you. Okay, boom. If I now only write P1 or P2, yeah, as you can see, then we see the plot. So the whole data command is stored in the variable P1 or P2. And why do we do that? Because we can do now something funny like this one. Ha! Now we have, with a slash in between, we have plotted the two plots in quite an intuitive way above or below each other. Patchwork is a really great library from Thomas Lim Peterson, and yeah, I can really recommend everybody to use that if they are working with subplots, because as you can see, the plots also fit really nice over each other. So you can really make an examination how the daily active addresses at a specific time behaved in contrast to the price and so on. Now, great, we have made our first plots, or our first set of plots, not only distinct plots. But I have to say I am not convinced with that, because the x and y axis labels are horrendous. We have already learned that we can change them. A figure caption might be nice, and we don't see that much regarding the price action before 2017, simply because the bull market overshadowed everything which happened beforehand. And a little bit the same can be said about the active address count in before, let's say, 2013. So let's change that a little bit. Let's make it better by simply adding commands. Let's at first look at the whole plot. What is done is, again, we make a normal plot with the color blue for the price. And here you see now scale log 10. Perhaps let's start a little bit there to see the difference. If I simply use that, I get a logarithmic plot. Great. In contrast to a non-logarithmic plot, I can see much more about what happened since the eve of Bitcoin regarding the Bitcoin price. So that we have done now, we can change the labels. If I have now written price in US dollar and year, I mean, of course, I could have made the same thing as in our first example where I simply skipped the information, but now I thought, well, let's write year there. And yeah, so we are, it's now looking much better. As you know, I'm not the biggest fan of the gray background, so let's skip the gray background with using theme minimal. So perhaps only to stress it, to change the labels on your plot, you simply change for X and Y, you can change it with this command here. And that can also then be done for the daily active addresses. That is done similar, but I would like to show the end result. Let's look at that. Isn't that beautiful? We really have a really decent plot in both cases. It's logarithmic and it is colorful, so it looks much, much better. That's also why I had it in a little bit larger in this presentation here. As we can see, with ggplot, it's quite simple to write complicated, nice graphs by simply adding a new information simply by using plus. Now, we already see, and there now let's start our analysis work a little bit. Let's look at the data. We see number go up, right? Yeah. And number go up both for the Bitcoin price as well as the daily active addresses. Okay, that's quite interesting. So the question is the what can we say about the correlation between transaction count I wrote, which is wrong. There you should have stand about the daily active addresses and the price. You can make the same study with transaction count, but I found the information regarding the daily active addresses a little bit more self-explanatory, so to say. And yeah, as I said, numbers go up. Let's look at the data. And now we don't show, as before, the data, the price or the active addresses over time, but we would like to plot the price over the active addresses and simply color this all with time. So we would like to make something like that. I start at first where we go step by step, like the new kids on the block. New kids on the block, blockchain, haha. And if we do that, we end up with something like that. Now we have a little bit the problem since we go over multiple orders of magnitude. We don't see that much, but we can work with that. We can at first make a so-called log-log plot out of that. So a plot where both axes are scaled logarithmically, and then it looks already much more interesting and yeah, much more clear. We really see a linear relationship between the price and the active address count. It really seems as if the price follows a corridor with a rising count of active addresses. We also, what I also have provided here, before we prettify the graph a little bit, I have provided time information, but that in form of color. That I did here with that as aesthetics. I not only had the x and y axis, but I also specified that the color should vary with time. So the darker the dots are, the older the information is, and the lighter it is, the younger it is. So this bright blue spot here is 2020. We were moving more or less around 10K, and we moved somewhere between, yeah, let's say 700,000 and 1 million active addresses per day. So that's simply as an information. We will discuss a little bit about why there is so little happening here. We'll discuss later on, but right now we only look at it. And we would like to prettify the plot again. That we do like that. Ah, yeah, and by the way, here I did something more. I made now, I think all in all, quite beautiful plot with nice X and Y labels, with a nice label above the color legend. I have included a title, a subtitle, and wrote the source of the data, which is also, of course, quite fair. It's valid information not only for the people who are providing the data, but especially for people who are reading your analysis work. We are again here at something regarding the falsifiability. If you only say, yeah, the data suggests that this and that happens, and another reader cannot confirm or challenge this hypothesis simply because he doesn't know the data, then you don't make good analysis work. Okay, if we do that, we end up with this plot, and I have to say, even though I find it quite nice to have this continuous information about time, I think it's oftentimes much more interesting to focus on the years, and that I did here. There I included, before I plotted, another axis. As we can see, if we simply look at Daten, we see we have three axes, sorry, another column. We have three columns. We have time, price USD, and active address count. But we can extend that via the command mutate. With mutate, you can, for instance, either modify one distinct column or you can make one new column. I made here one new column where I look at the year of the time, and that I would like to have as a character, not as a number. So the difference is that is now a string. To show you why I did that, there I have to say better show, not tell, to say it like that. If we use that, we end up with something like that. And I find that quite interesting and beautiful, because you have now really regarding 2000, you can distinguish between 2018, 2019, and 2020. You see the bull run of 2017. You see the bear market of 2016 to 2015, and so on and so on. Now, not to the question I asked myself, so to say, why have I changed the year, or why have I labeled the year as a string, as a character, and not as a numeric variable? And that is because if I do that as a numeric variable, ggplot will think that the color axis is a continuous axis, but I wanted to focus at the discrete year, and the discrete year should not be continuous. So, and that is can be done by simply giving for a human as a numeric information, readable information, to the machine as a string. And since the plot is so beautiful, we have also included that in the presentation, of course, as you can see here. Now, of course, there are possible interpretations, and yeah, higher prices garner interest, so regarding buying and selling. And one model which can help us to get some light on that is the so-called Metcalfe's law. Initially, the Metcalfe's law had nothing to do with Bitcoin or with price development, but it simply said that the value of a network increases with user count. So that was, for instance, quite important for telecommunication networks or something like that. That would, for instance, mean that the value of a network is proportional to the square number of users at Metcalfe has specified. And for Bitcoin, we could summarize that in that formula here, that the price, according to Metcalfe's law, the Bitcoin price, according to Metcalfe's law, should be proportional to the number of daily active addresses as a model for the user count, and this squared. And yeah, how could we see that now? There, a log plot can help us. What I plotted here is a simple plot where we see something rising with a quadratic rise. So not with a linear rise, but with a quadratic rise. If we plot that on a double logarithmic scale, on a log-log scale, we see it simply looks like a line. So if that is true, or if that is a valid model, we should see a linear behavior, which, of course, we already can a little bit confirm. But we also would like to model that. And for that, we have to install another library. And that is called modeler. Modeler, bam. Now we have also included modeler. And at first, we will use the Daten. Okay. Now we would like to model it, and that we do with that command here. What we do there is that we assume since we are again we are assuming a linear increase if we plot the data double time as a log-log plot, as a double logarithmic plot. We would like to see whether the logarithm of the square of the daily active addresses. Of course, we could also write 2 times the logarithm of the daily active addresses is proportional to the logarithm of price USD. And we check the linear fit of that with this command here. Let's do that here. And what we then have is that we see then there the coefficients, and we can use this whole data to visualize it. Yeah? And we can afterwards play a bit more around with that. And let's start by making the plot as simple as it can be. Let's see. Ah, yeah. Okay, now of course you don't see that much. Why don't you see that much? Simply because you have now not a log-log plot that we have to include. What I also have included is I tried to make some support and resistance in it. I will show it to you what I have done, and that can be seen here. I'm currently a little bit unhappy with the look and feel of this plot, but we can also look at that here. And yeah, how did I do that? You know what? I will write that in a new script simply to explain it all in all to you. First of all, we write again the year as character, as I told you, and then we have then this here. We add predictions. Let's see what that means. That means, if we do that here, that he also writes predictions for this interaction here. And as you can see, okay, you have at the beginning where you have no active address counts at all, then obviously you will end up in something negative. But you have included the predictions based on the model we discussed beforehand. Let's really copy paste the whole code here. Okay. Based on that model, we created some predictions, and just to show you again, the model is daten mod, and yeah, based on this formula here, with add predictions, you calculate values for the price based on the daily active addresses. And what I did then was that I focused a little bit on address counts which were larger than 300. The main reason was that these were then destroying a little bit the graph, but that is purely cosmetic. But what we did then was, again, we made a ggplot where we, first of all, only focused on the active address count, as you can see. Then next, we included geometric point data. You know what? Let's do that which we can do best. We go step by step. And if we do that, we end up with that at first. Yeah? As I said, I'm a little bit unhappy that the graph now looks such horrendous. Ah, it looks better. But now we can go a little bit further. Now we can we can include the predictions. We called the predictions are called pred, like predictions. Yeah. That is the standard column name that might be changeable, but for our case, it doesn't have to be changeable. If we include that, then we see here that quadratic behavior. In this type of plot, it here, as you can see, it looks horrible. But on the other hand, we must not forget we would like to fit over the whole scope. What I now tried to do as a second thing was to add additional lines. We have now points indicating the raw data. We have a black line indicating the model, and I wanted to include one support and one resistance, to say it like that. What, according to Metcalfe phi should be the upper or lower bound of our calculations. And then we end up, again, in this plot with something like that, so with a huge spread. And now we finally do something which makes this whole stuff a little bit more observable, because we look at it in a double logarithmic scale. And as you can see, that is now quite interesting to see. We really have something, as I already explained, such as a corridor, where in bearish times we oftentimes touch the support. Oftentimes is obviously a little bit exaggerated with 2 full cycles we had. In bullish times, it's oftentimes that we hit the ceiling, so to say. And if we now use this model, it could be that we end up with something quite sad, that our support and our current value regarding to Metcalfe phi is quite low. To show that, let's look at the raw data and there on the tail. Okay, dip, dip, dip. If we do that, then we can mutate another thing, and that is now pred equals x pred. If we do that, and now would like to see the tail, we see that according to the prediction, we would have a Metcalfe phi fair value of 5,000 US dollar, which is quite disappointing. And it even gets more horrible if we look at the expected support and resistance values. And yeah, as you can see, we would end up with really horrible values for the model, for the support below 700 US dollar, and even for the resistance. So what can we make of that? I mean, just to talk a little bit about the limits here. First of all, that was a model, let's say, for training purposes. We are doing now a small analysis work, and we can also discuss a little bit about the limits of the model here. I mean, what that model doesn't include at all is the rise of off-chain transactions, both on exchanges and in the Lightning Network, Liquid, and whatnot. Batch transactions aren't included either in this view. To do something different, I would like to focus now on other cryptocurrencies. What we do here is, again, we work with the data from Coinmetrics, and there we would like to not only look at Bitcoin, yeah, which we would do with something like, I have there, delete that at first, with something like that, that would simply be the Bitcoin we all know and love. But we would, for instance, like also to look at BSV as an example. And now the problem is we would like to have all the data for several coins. To be specific for BSV, here's an error for BSV, BCH, ETH, LTC, Maker, Tron, etc. We would like to have quite a bunch of information. And to do that, we define a function. We define a function called getStuff, quite simple name. A function which has as entry values the base data, so the already in a tibble stored data, and the currency we would like to add to that. And what we do with that is we pull this new information, rename the price USD and act other columns to something where the name of the currency is included, and add that to the base data. That is all done with the function. Right now, we haven't invoked the function. For that, we have to have two things. First of all, we have to have a basis of data. Boom. Again, our old Daten stuff. If we look now at Daten, we see there we have the price BTC and DAA BTC. And now we start that, and as a side note, I will change that, because if we would like to do that, we would end up in an error, and we don't want that. Shall we include BCH? Yeah, why not? Then we have something here which we don't have in the talk. And if we now would like to build up our whole data set, we run a loop where we extend this daten. I do that, and while it's running, I can talk a little bit. You can see it's now running through the loop, right? And now if we look at that, we see we have a lot of data for BTC, for BSV, etc., and a lot of variables. What we do now is that we make a little bit more data tidying. Yeah, you know, data tidying means that you try to bring the data in a readable format, and for that, at first, we put all price information. So all columns where we have price information, we would like to make them in one column and one column only. And if we do that, it looks something like that. Yeah? Then we have something where we see the currencies and we see the prices beside that. Quite neat. We can do the same with the daily active addresses. If we do that, then we end up in something similar. Okay, now what we would like to do is that we combine these two long lists in one combined lists, where we have for the respective date and the respective currency, the price and the daily active address. And that we do by, with a left join command, where we say we join these two data sets by confirming that the time and the currency is equal. And if we do that, then we end up in some beautiful data set which looks where the first 10 lines look like that. Of course, here we don't see that much, because that is quite far in the past. We might simply to see what the data looks like, we can then look at something like that. And then we see now the last 10 lines there. Yeah? And yeah, as you can see, we have price information, we have daily active address information, and we can now use that to plot the data. And if we do that, we plot the daily active addresses over the prices. As a color, we colorize this whole thing by the currencies. Everything should be plotted as a scatter plot. We ensure that we have a double logarithmic plot, make some other, let's say, cosmetic additions to the plot, and we end up with something like that. Let's look at that a little bit larger, because I think here we are at something which has not yet been discussed that much. Perhaps let's look at this plot here, because we have here one plot more than in our presentation, the one subplot, the BCH. And what we see is a lot of cryptocurrencies follow the general trend of Bitcoin. Yeah? So a lot of it is somewhere around here. Bitcoin Cash is a little bit above Bitcoin regarding the price of the transaction, but also LTC completely follows Bitcoin. ETH most of the time follows it. It has some outliers here. There it would be interesting to see at which time. Even XRP is following more or less Bitcoin. Stellar Lumen follows Bitcoin for the most part. It only has here something worth mentioning, which would also be something worth of examining. The only two huge outliers here are, first of all, Tron, which is here. Tron has, for its monetary value, quite a large number of transactions. So according to Metcalfe, you would say, in contrast to Bitcoin, it would be undervalued, and Maker would be overvalued. I would say for both of them, it's a little bit a different thing, because I would say Metcalfe's law shows a little bit more where the store of value dominates and where the medium of exchange dominates. And now we know that Tron has a lot of dApps, which are such as Tron Dice or something like that, are quite active. So it might be that this is the reason why we have there, in contrast, quite a huge transaction count, or daily active address count. That sorry for that mislabeling here. And for MakerDAO, we have a classical hodling token. Yeah, MakerDAO, the Maker token is not there to as a medium of exchange. It's there for the governmental purposes and the lending purposes around the DAI stablecoin. So it is quite understandable why that move is quite far ahead. Yeah. So, sorry, wrong window. So we are now quite far, both in our screencast as well as in our time, what we can learn from that. I already said that we can see, one idea would be that we see different areas for medium of exchange and store of value, that something above this diagonal line is more, has more a character of a store of value, and the things below that have more characters for a medium of exchange. Of course, as every good analysis work, it's not finished. Relative values could be further analyzed. We could look at distinct times, as I said, that what is with these Ethereum outliers and so on. We could also look at the total, at the relative values regarding the total supply of a coin, and yeah, and we can also look at the transaction volume. We have no focus on the daily active addresses. Instead of that, I would like to finish with looking how we can turn that into an app. The app which we will have in the end, let's fingers crossed that it works, and it seems to work, which is great, looks then like that. We have here then something where we can see the asset, and we have now something where we can add other plots to it. For instance, let's say we add, I don't know whether decrypt works, but let's see that. Yeah, so in that way we can then end up with some small tool where you can look from, let's say, a Metcalfe fee perspective, how the daily active addresses and the prices of different crypto assets, how they behave with respect to each other, especially to Bitcoin. Yeah, and how would we end up with something like that? Let's switch from we have now worked all the time in the RStudio. You know what? Let's work in the RStudio Cloud, because that is for today our environment, right? And let's simply open the correct app and hope that it works there, right? Package Shiny is required but not installed. Let's do that. That again gives me an opportunity to drink a sip of Coca-Cola. Side note, if some people from RStudio are listening, I find it quite interesting that it takes such a while to install something if you click on install, in contrast to writing install packages. But that is a small side note. Okay, what we do is here we again start with several libraries in that sense, because we would like to make a Shiny application, something similar to what we already have seen in the talk, but standing for itself as one, let's say, distinct web app. We also need the Shiny library. What we do then is that we look at the community API from CoinMetrics and download the assets and metrics which we have. That we do with this command, with these two commands here. Again, here we again need the from JSON command, and if we do that, we end up with assets and metrics. Theoretically, you can, on this basis, even write something more complex where you look at other data and so on. But yeah, we only focus here on our little Metcalfe fee experiment. What I did afterwards is I looked at the so-called asset info raw. What I did there was, there I wrote down the ID, the name of the asset, and what metrics each of these assets supports is written then down here. This information we use for two things. First of all, to have some variable where we only have the asset info, so that something with the ID ADA is named Cardano and so on. And the other thing is much more interesting. Here we have now the information which assets support which type of metrics. Yeah, what we did in the second part is we have a getData function. That's simply a long form of constructing again an API call. With the help of paste0, we can combine different strings with each other and construct in that way a URL for an API call. And the only thing we do then is that we label the asset by the variable asset. Quite simple. We have a similar function called addData. We have then the function which glues all together, getAllData, which is again a function of assets and metrics, where you then combine the data of the first asset and then glue it together with addData. So far to our core functions we wrote. How do we use that in our Shiny application? A Shiny application always has two parts. First of all, one part defining the UI for the application, where you simply state what kind of elements you would like to have on your page. So for instance, you would like to have something where you can specify the asset, which I have here. Another part where you define the output. You remember what we had done here. It's similar, even though a little bit simpler. For a web app standing on its own feet, it's a little bit more complicated and depicted here. And the second function is called server, and there you write down what should happen when and where. And what you do there is you render a plot based on the asset. And if only one asset is chosen, you call getData. If several assets are chosen, you call getAllData. And on that basis, you fill a variable called Daten, which is then piped into ggplot, and the plot is being constructed. And you can play around, of course, with the code just to show it to you and to show to me that it still works, because I was now a little bit bummed that this web app hasn't worked when starting it from rstudio.cloud. But yeah, there I have to see what the reason is. If somebody who is listening knows an answer, he of course can tell me. Yeah, okay, now we are quite far ahead in our journey. We made this dashboard. You can play a little bit around with it. It's simply a way of presenting the data. And this talk is also a way to present the data. Now, I have here now written group work ideas, because the main idea back at the workshop was that after my talk, we begin with some group work. But let's say for this screencast, that is a little bit seen as an inspiration for you. So besides looking deeper in this whole Metcalfe thing, which I already said, you can also look at stuff like stock to flow value, which I mean has had a lot of airplay in the Bitcoin community. You could look at stuff like how much gas would Tether use. You could look at the dApps in different ecosystems, the Lightning usage at Bitcoin and Litecoin, or the P returns of Bitcoin and versus Bitcoin Cash or Bitcoin SV. You can look at the mining distribution at the different blockchains and so on. With these tools, with R and APIs, and of course RStudio and Shiny, you have everything together to make quite thorough analysis work. I have written or started an awesome list, which is here, awesome crypto APIs, where I listed several APIs which can help to get information regarding these example tasks. If you have other ideas, other APIs where you think they should be mentioned here, you can of course make a pull request, or simply write to me that I should include this and that and so on. The last thing which I wanted to mention are some literature recommendations. Humble as I am, at first I would like to give some information about some article series which I wrote in German on my on BTC Echo back in the day. I have it here. Of course, these are German speaking, so might be not for everyone, but of course you can look via Google Translate or something like that on these articles. What I found quite great for more advanced data analysis work in the field of cryptocurrencies with R is the book Quantitative Finance with R and Cryptocurrencies from Dean Fantasini. It's a really interesting book where you really deep dive into econometrics and do that all in the crypto business. If you would like to have a little bit more broad introduction into data analysis with R, which is also a really solid fundament for doing analysis work in the cryptocurrency field, I can highly recommend R for Data Science. I already mentioned the book. The nice thing is the book is available for free online and that completely legal. So it's let's say one standard literature regarding R. And out of the, let's say, community around R for data science, evolved the Tidy Tuesday, which can also be inspiring for one's own analysis work, where each Tuesday the community around R and around the Tidyverse looks at specific challenges all around data analysis. There's a nice video series about that on YouTube from David Robinson, who looks at these tasks and make some solutions about that. Okay, now I have done everything. Thank you for your time. And if there are some questions or something like that, of course, you can shoot me a message. I will have some contact info in the show notes. And would be nice to see some analysis work done in the cryptocurrency field, because I think, as I said, we really need solid, calm, well-reasoned and falsifiable analysis work.